Hi, and welcome to Matchmove For Production by VFX Tutors. I'm Josh, and in this video we'll be starting with the shot MM001. What I'll do first, we will just play through the shot first and have a look at it, then we'll open up 3DEqualizer. So I've opened up 3DEqualizer and we can see that our user interface is this big grey rectangle. Doesn't really show us much, so what we want to do first is change our UI. So if we go to environments and click on basic, this will now give us a basic user interface setup, and all these windows that have popped up here now will use throughout creating the shot. I won't explain right now what all of these windows are and what they do. We'll just do it as we go through the shot, and you'll get a much better understanding of what all these things do. So first of all, we need to load in our image sequence. So if you've downloaded the data package, that's great, because you'll be able to follow me step by step through this entire tutorial. And also if you wanted to do more of the shot and maybe add some CG visual effects to it, you'll have all the data to create really nice visual effects of it. But if you don't, you can still follow through with your own stuff. You just might find it difficult in some parts if you don't have the same amount of data as I have, or if you do have the same, that's fine. It will just be the same process. So what we'll do, if we select our camera up at the top left in our object browser, we'll have a camera in here which is highlighted yellow, so that means that our camera is our active camera. And at the moment we have no image sequence on it, so it's blank. So if we select this and go over to our live action footage, and if you don't see that, you might be in another one of these tabs, so you need to make sure you're in this camera tab here. And you want to go to live action footage and click browse. Now you want to navigate to your image sequence that you're using. So if you're using the data package, you'll have the garden table. If you open up and you go to plates, you should have 179 frames. If you're not seeing that, if you're seeing something like this, you want to make sure you check sequence view so you load in all your frames. So if you click OK. So now we've loaded in our image sequence. And we can see it's a garden table. It's looking very dark. It's because this image sequence has already been transcoded into a linear color space for you. So you don't have to worry about converting any of these plates. When you bring them into your different softwares, they'll have LUTs that will all be automatically applied, usually an sRGB LUT for viewing. So, and what we have here, we don't have those LUTs, but we can do what's called an 8-billet color correction. So if we go over to our right and click on this little arrow, we want to go to our gamma and change this to 2.2. And now this will bring our viewport up to a much more reasonable viewing color space. So now if we click on our timeline, we know it's quite jumpy and we can't really play through. If we press spacebar, it's not very useful for us, especially if we're working on an image sequence. So the first thing we need to do, we need to cache out this image sequence. And we do that with an image buffer compression file. But first of all, we need to save it. So if you go to 3DE4 in the bottom left, click Save Project As. And what I'll do on here, I'll make a new directory. I'll just call it tutorial. You'll obviously save it in something that's probably more useful to you. But so now we need to type in our file name. We need to make sure that we call this the same name as our image sequence. So we always know that this file correlates with this image sequence, and whatever files that we create from this correlates with this. It's very easy to get stuff mixed up, and it becomes chaos very quickly. So I've called it the name of the image sequence plus underscore cam, and it's the version 1. So now if I click OK, I've saved it out. So now if we go to playback here, we want to export the buffer compression file. And this could take a while, so just be patient. It will do it in its own time, but I'll probably fast forward it. So you might want to pause or just watch it. Okay, so that's now exported. So our next step would now be to go to playback, if it's not already open, and import our buffer compression file. And that'll be super quick. So now if we press spacebar, we're able to play through our image sequence and see what's going on. So everything's super quick. So now we've done that, our first step is to set up our lens to the best amount of data that we have. So if you go into your data package and go to your camera data file, you should actually have a little notepad with some camera data, this. So there's not actually a lot of data. So the things we're going to try and do is we're going to try and do minimal amounts of data here and there, but we'll try and get around to explaining some of the most important parts and what we can do with and without data. So we've got what our camera is. It's a Blackmagic projection camera 4K, and we know our sensor size from that. And the lens we're using is an 18 to 35. So you have been supplied with all your lens grids. So mostly what we'll be doing is going through the process of how we would figure out focal lengths first throughout this course. Because it's something that you'll probably do quite often instead of always just being given it. So we'll start off with one of the parameter adjustments for that. So we've got our sensor size. So if we go over to our lens tab, our sensor size is basically our film back in here. So what I usually do, I will put in my film back height, which is our sensor size height, and I'll leave this as fixed and put this as passive. So hopefully when we type in our film back height, it will still correlate to the correct number in here. So 11.88, and you need to make sure that you put millimeters, because it will auto convert to centimeters. If you don't, then you'll end up with 11 centimeters instead of 11 millimeters. So if you press enter, and now you can see that our film back width is at the correct value. And what we'll do, we'll leave our focal length as it is, because I know what it is, but let's pretend that no one knows what it is. So we'll leave it as 30. So our next step would be to bring in our set geo so we can figure out our focal length. So what we're going to do is go to our top left, and go to our point groups, click on the little arrow, and on 3D models, right click and add new, import OBJ file. So now what we want to go to your garden table data and go to set geo and bring in your garden table set geo OBJ. Click OK. It's super quick because obviously you can't see anything here, so because we're on our manual tracking view. So now if we press F5, we can see these lines have appeared, and this is our geometry at the point of origin. So if we click center models here, we've now centered. Well, we haven't moved our geometry, we just moved the camera's been pushed back so we can see our model more. So if you press shift and hold down left click on your mouse, you can rotate your scene around your geometry. So you're not rotating the geometry, or the geometry is always fixed, you're just moving the camera. So if we left click and rotate it around so we've got a fairly reasonable angle, then hold shift and press right click, and this will bring us in closer. What we want to do, we want to try and get this lined up fairly close. So if we hold shift and click on the middle mouse roller, that will allow us to translate it down a little bit. Hold shift and left click to rotate around again. And we don't have to get it perfect, we just have to get it within a reasonable amount of distance. So I'm quite happy with that. So what we want to do, if we go to our 3D models up here, and if we click on garden table, it will automatically open our 3D model tab. So what we want to make sure, even though it's low res, we still always want to make sure our model's on reference only. It's just a very good habit to get into, and later on when we start using heavier mesh like scans, it's because when we won't be using these sort of really nice low res models, we will move on to doing like big heavy scans later on. It's always a good habit to put reference only on. So the good thing about this, because this has all been built for you, so we'll go over to here to where it says UV map, and we'll go to the Set Geo Texture, and we'll go to TIFF, and you won't notice any change. So you need if you check Show Lines, then click on Show Polygons, and now you've got your textured model of your Set Geo, and you can use this button here, 3D Models, to flick between the two. So we've got a pretty close lineup, but it's not. It's nowhere near the level of what would be required of a production camera. So what we can do, if you leave that on, we can look at our geometry. So you've got some pretty good detail on our textures, and we can start looking at points that we can line up. So what we'll do first is something called a single frame lineup, and so we'll go to press F2 to go back to our manual tracking. So the most important thing about doing your cameras is getting these lineups absolutely perfect, because it will mean that you'll get very good solves from them. If your lineup's really good, then your solve's going to be really good. But not only is that, it's because when you're working with pre-made Set Geo, people in layout would have already used this. People will be working around this table. Say you had something running across it or landing on it, they would have already done the animation for it. So they're expecting you to make the camera work with this. So it's really important that we get a really accurate lineup. This is what a lot of other match-moving software doesn't do. So this is what will be required for you if you ever get a job in Matchmove. You'll need to make sure it's surveyed absolutely perfectly to pre-built Set Geo. If not, or you have to make your own. So this is why we're going to go through this stage of making really good lineups. So what we can do, we can turn our lines off again. If we press F2, what we want to do, we want to make these single frame tracking points. So you can pick a frame of what you want to line up on. Generally, when you do your lineup frames, you want to pick the frame which has the most in. But what I'm going to do, I'm just going to pick a central. I'm going to pick this frame. So the table's central. Doesn't make any, for this shot, it doesn't really matter because we see a lot throughout anyway. So you notice you've got these crosses in the middle. This is your FOV, but these are kind of your lens sensors. So you can have multiple. It's basically your offset for your lens. So what we can do, we can turn this off because we won't be needing this. And click Show FOV. So now what we can do, we can find points. So if we go to our table, and I quite like this corner, so if I want to make sure we survey this, because this is going to be our most important part. So if I hold Control and click left mouse button, we've created a tracking marker. We're not going to solve this, we're not going to click track or anything, we're just going to leave as it is. These are going to be our single frame survey points. So if we press Alt and left click, we'll deselect it. So now what we want to go is do this other corner. So we go Alt, left click and make another tracking point. And let's say we're not tracking it, we're just leaving as it is. Press Alt, left click to deselect. It's quite hard to see where this corner is on here, but I can see it much clearer here. So I'll Alt and left click here to make another point. And we'll go to the right here and we'll hold Control and left click and make another point on that corner. So we've got 4 corners done here, but we also want to put some more over here. So that looks like a fairly significant white spot there. So Control left click on that. We want to get a very good spread of points. So if we go to the corner of this brick, Control and left click to make a single point. And we'll do some stuff on the ground. Say like this leaf here. Control and left click, and what we'll do something up here. So we'll pick this knot in this bit of wood here. And so if we select all our points, we can see you got a pretty decent spread, but we're kind of missing something here. So let's get the cat right on the nose. We'll Control left click there. Cool. So if we select all our points, We can see we've got a pretty decent spread. Maybe actually let's have one more up here on this white spot. So now if we select all our points, you've got a pretty good spread. So now what we're going to do, if we select our first point and we press F5, we can roll on our mouse and zoom in, because we know that if we can flick between F2 and F5, or you can turn 3D models off, but I kind of prefer to do F5 and F2 because it's just out of habit, don't know why. So with that selected, if we click extract polygon, this will give us this zebra line, which means basically what we're doing here is we're surveying this 2D point and giving it a 3D representation in space. So when we click here now, we've got this green cross, and this means now if we go to F6, we've made 3D know that that 2D point is there in 3D space. So now what we want to do is go to F2, we'll select our second point, and we'll go to this other corner, and we'll press F5, and we'll do the exact same thing. We'll go, with that point selected, we'll go extract polygon, we'll get right on the edge, and if we go back to F6, we can see now our 2D point has now a 3D representation in this world space. So we want to do that for all our shots now, all our points, sorry. So on our third one, we're not on the corner, but we're in this little dark corner bit here. So if we press F5, extract polygon, we can get just about in there. We'll select our fourth point, go F2, go to F5, extract polygon, we'll get right on that corner. Don't worry that these are not right on top of each other, because this is most definitely the wrong focal length, but this is what we're trying to figure out. You're not always going to be given data, so if we start trying to figure out our data logically and correct from the start, it'll be much easier later on for you. So if we go to our fifth point, and it's on this little white splodge on this little brick on the wall, you can just about make it out here. So if we go extract polygon, click on that, and it's done the same thing because it's the wrong focal length. So if we go to our sixth point, and we're down here, this brick on the corner. So if we look at our plate, we can see this like rectangular light patch, and above that is our corner. So we've got this rectangular light patch here, and there's our corner. So if we extract polygon, we select on our corner, we go to our seventh point, which is this leaf on the ground. So we press F5, extract polygon. We can see that this is that leaf there. You can see they're getting quite stretched because we're at the wrong focal length. But once we've surveyed all these correctly, we'll be able to solve it. So we're on our eighth point, which is on this piece of fencing. So we go to F5. There's a couple bits here that look very similar, so you need to make sure you get the right one. But we can see this dark nail hole here, and it's the one below that. So we've got dark nail hole, and it's here. So if we extract polygon, and we click there, we go to our ninth point. Our ninth one is right on the cat's nose, so it's kind of a bit dodgy here on the geometry, but we can kind of figure out from the texture. And if we go to our 10th one, which is up here on the wall, and this white splodge, which we're pretty close to. So cool. So we've done that. Now if we press Alt-C, if you hold Alt and press C, it will open up this window. This is like your 3D solve window. So because we've only done a single frame, you'll only have one keyframe here. But all these yellow dots are your 2D points in 3D space. So if we click Use Result, and you click between your 3D model, you can see this is not working very well. So because we're at the wrong focal length, we will now solve for a more correct focal length. So we can leave everything as it is because we know this is accurate survey, and that's where you have to trust your survey points. So if we go over to our lens tab here, we have our focal length, and it's definitely not 30mm. So what we'll do, we'll click on fixed, and we'll change it to adjust. And now that's changed it. Now that's at adjust. We want to go to our windows here at the bottom left, then parameter adjustment window. And what it's done, it's opened up this adjustable parameter in this window. And what we want to do, we want to make sure we change brute force to adaptive. Then we can click adjust, and you can see here, this is the focal length that is figured out from our accurate survey data. So if we transfer parameters, so it looks a bit crazy, but if we hold Alt and press C and use result, you can see it's readjusted to the position. So now if we click between our 3D model, we can see almost no difference between the 3D lineup and our image sequence. But there will be some slight distortion on this. So because we have the lens grids, we'll still do a lens grid. So to do the lens grid properly, so what we do, if you go up to your garden table here, and if you right click on it, you select it, then right click on it, you go add new, reference camera, and it will make a reference #2 camera. And if you double click on this, it will all go grey because you don't have an image on it yet. So from our accurate survey, we can see that we've got a 23.53mm lens. So what we're going to do, if we want to go to Ref 2, we want to double click on this and go to Browse in our live action footage. Then what we're going to do, we want to go to, in our data folder, go to lens grid, and we have all our lens grids here. If you click on sequence view, you can see all of our lens grids. What was that? That was a 23mm lens. Was it 23? So what we'll do, we'll go with 24. That's going to be our closest bet, I think. So if we go OK, and we want to press F3 for our distortion grid. And you can see here in the middle, we've got our distortion grid, and we've got these little red lines and dots here. And this is basically our distortion matrix. This will figure out our distortion for us, and will flatten our plate basically. So I always pick this top left one first. Then if you click and drag on it, you can see there's a zebra line. If you let go, it will snap straight into that corner. So we want to do that to these corners. So if we select this one here, and we click and drag it to the corner, we want it to snap in there. And let's do the same for this one here. And so we want to snap it into these corners exactly like this. Because we've got quite a good lens grid, and it's quite clear, if we click snap here at the bottom middle, 3D will figure out exactly where it needs to snap to next. So our next step, we need to fill out this entire lens grid with our distortion grid. And the way to do it, if we hold Control and press up on your keyboard, you'll start adding more rows to this column down the middle. So you can see we keep adding it to the top of it. And if we hold Control, so we can go all the way up to the top. But if we zoom in, we can kind of see we're going to lose it after a while. So we'll see how that goes afterwards. So if we hold Control and press down, and we'll keep adding, extending our distortion matrix. So now if we hold Control and left, we'll start to see at the top, it will go off and it will start deactivating them for us. And you see how it's going a little bit funny because it's activated once. So what we'll do, we'll actually select these and disable them so it doesn't affect any more of this, because it will start leaning down. So now these are disabled. So if we hold Control on left, keep going until we completely fill the lens grid, and you'll see you get this little weird, these little grayed out ones. Don't worry about those. These are all automatically disabled. They won't affect us in any way. As long as they're grayed out, it's absolutely fine. So if we hold Control and go right, we want to add all our points to the right. So usually you would want to fill this out, but because the lens grid was shot kind of possibly on the wonk, we've not got all the corners, but it will average itself out. So now we've got this completely filled out. We want to go up to the top, click Calc, and calculate distortion and camera geometry. You don't need to change anything here. Just click Calc Lens Parameters, and it will come up with all its parameters in here. See what it's solved for. You've got a really low pixel deviation in here, which is really good. So now we need to set parameters and close, and it looks like it's done nothing. But if you click on this undistort button here on the bottom right, you can see it's done a really small amount of distortion, almost nothing. So we're now done in this. So if we double click on our garden table camera, highlight it in yellow, then press F5, then press Alt C again. We can flick between our 3D models. What we'll do another focal length solve. See if it changes. It's absolutely fine. So we'll Alt C again, solve it. Flick between it, and it looks absolutely perfect. So if we go to our 3D model, if we select our 3D model, here over in our point groups, we can turn off our polygons and we can show our lines. Make sure your 3D model's on. Now we can zoom in and have a look and see actually how close this is. And you can see it's pretty bang on. These gaps are lining up, which is going to help with any sort of animation, lighting, shadow cast off going down these gaps, or if you're putting a light going through it or something like that. Whatever you're doing with it, the lineup's pretty good. It probably needs adjusting in some areas, but in this case it's pretty good. So now we've got our single frame lineup done. We want to go to Store Pose and see what it's made a red key here, so it's keyed the camera at this point, so we can remember that bit. So if you do break it or lose it, you have Recall Pose, but right next to Recall Pose is Remove Pose, so sometimes you can click on it by accident in a rush. But with these points, we'll keep it as a safety, so we can always go back to our single frame lineup. So what we want to do, if we select this top one, then Shift and select the last one, we can right click, add new point set, and we'll call this SF. So we made a little group called SF for single frame, and now if we select all these points again and middle mouse click them into here, so now you've put them under this group. So now what we want to do, we need to make sure these are disabled, otherwise they'll cause havoc with our solve. So if you right click on this and go to Modify, we're Calculation and Disabled. So now they're all off, and if we click View, we want to hide our selected points, so we don't need them anymore. Now we click on this triangle and it hides the group, and now we can go press F2 to our tracking menu, and we're at frame 9. So what we can do, we can go all the way back to frame 1. I always like to start, you can track from any frame, but it just means if you track from frame 1, it's always going to track the entire range. So what we'll do, we'll pick a point on the table, and we'll do the same as we did before. Hold Control and left click to make a tracking point, but this time we'll gauge the marker and we'll track. And you see it's kind of floating around everywhere because we don't have it centered. So every time you track, you need to make sure, every time you're doing some tracking, or the 2D tracking side of it, make sure you're on center 2D, because you'll be able to see what your actual 2D track's doing. So now if we click here, we want to make this tracking box a little bit smaller, because we don't want to track anything in this background, because it will try and track it and it will force with the difference in parallax, it will go funny. So what we can do, we can readjust our tracking box here. So this is our pattern box, this is the pattern it's going to be looking for, and this is going to be the search area. So if we gauge marker, click track, you'll notice that we're actually tracking backwards now because we started on the last frame. And see how it's centered on that point at all times. So we can see if there's any bumps in it. So if we do this corner over here, see our tracking box is shown, but we don't want to see any of this background because it'll go funny. So if we click the edge and reduce it, and reduce our search box and click gauge marker and track, we can see that we're pretty locked on this position. And now let's do this corner as well. Same here, it's sort of overlapping, so what we'll do, reduce it, gauge marker, track. So now we've tracked our 4 corners. We also need to track other things around as well. Pretty much the same as our single frame, so we get the best out of our solve. So we'll do this little corner down here. Control left click to make it, and gauge marker, and track. So you need to make sure you deselect your points every time, because whilst you still got that selected, you can click and move your point around. So if you hold Alt and left click, you deselect it. So if we Alt and left click here, gauge marker and track, we'll just get a really nice spread of points. Alt left click, gauge marker and track. And we'll get something on this fence. Gauge marker and track. So the gauge marker takes a little snapshot. I'm pretty sure it does it every time when you click track anyway, but it's nice to always double click on it and check it. So what we'll do is do this leaf down here as well. Gauge marker and track. So if we select all our points, we can have a look at what spread we got. We've got a pretty good spread. If we scrub for our timeline, we've got some pretty good tracks that are throughout. So now if we go to F5, and we want to scrub on our timeline to our red key where we've solved our single frame. And what we can do, if we have all these points selected, we can go edit and project points onto 3D models. You see only 8 of 9 have projected, because something goes a little bit, because something goes a bit funny with the clipping plane, so we have to zoom in a little bit and edit and project points of 3D models, and that's that. So now all your points in here should say survey. So now if we press Alt C, we'll open this window now. Instead of seeing one keyframe, we now see quite a few. And these are the keyframe, this is the animation keyframes of your camera now. All these keyframes. And these yellow dots are your 3D representation of your 2D points in 3D space. It's quite confusing, but this is where we surveyed it to. So if we click use result, we can see we've got quite a V-shaped deviation here. So this little browser will give us indications of what's going on in our solve and what we need to fix. So ideally this graph needs to be flat. So this is a good indication that there's something quite not right with our track. So the first thing that we will do is go to our parameter adjustment window, and we'll just clear that and we'll adjust it one more time, see what changes, and nothing's changed, and we'll resolve that. So we've definitely got something wrong here. So if we go to our deviation browser window here, if we go show point deviation curves and active points only, this will show all our 2D points. So we've got one here that's quite high up, and it's it looks like it could be affecting quite a lot. So, and it's quite possible because we've projected this onto a flat plane. Obviously this fence is not completely flat. There is depth in this fence, and the smallest amount of incorrect depth projection, because we've projected this onto a flat plane, and this is effectively not a flat fence. This could be causing some problems. So what we'll do, we'll right click on it, go modify, survey, and we'll survey through it. We'll just unsurvey it for now. If we click Alt and press C, we'll resolve it and use result, and you can see that's fixed it quite a lot already. So now if we press F6, we'll go into our 3D menu where we can look around and we can see where it's kind of put it. It's kind of put it behind the fence. So if we go to F5, we can actually project this back on. So we've put it back in the same place, but we can right click on our point, and if we go back to survey, and we can approximately survey it, this will basically give us some wiggle room for it to sort of relax. So with that selected, we can see that our approximate survey radius is 10 centimeters. So there's no way there's a difference of 10 centimeters of where that's being projected. So that's a fairly reasonable amount. So if we now Alt-C to solve again, click use result, you can see it's not changed anything, but we now know it's been surveyed to that point in reasonable depth. So now what we'll do, we'll go for this other one that's been peaking up. And this could be the same, although this is not flat. This could have some sort of buckling in it, so we'll do the same. Right click on it and we'll survey free it first. Click Alt and C and save and use result. You can see it's completely flattening it out. And then what we'll do, because we'll survey free it so it sort of relaxes the camera position. Then what we'll do, we'll reproject it back on, but then we'll change it. Then we'll right click on it, modify, survey, and we'll change it to approximately surveyed. Then we'll hold Alt and C to solve again. You see it's not made any difference, but we've surveyed it. So if we have a look at some of these other ones, this could be the same. So if we edit, if we right click on the point, go to modify, calculate and survey free, press Alt C to solve again. See we're flattening it out. And if we edit, project it back on to the position on the geometry, click OK, then we right click and we can approximately survey it. And press Alt C again to solve. And then we'll have a look at this other one. So it's probably that these things are not perfectly straight, whereas in this geometry is probably made a bit too straight. So if we survey free and hold Alt and press C, we've now pretty much flattened it out to 0.15, which is really good. So now if we edit and project it back on to that geometry, then we'll Alt C and see what that does, and it'll probably do the same thing. No, it's kind of still leveled it out. And what we'll do, go away AVG, we will clear that and we will adjust our focal length. And we'll Alt C, well it did nothing. So now if we kind of click full frame, press spacebar, we can play through our camera. And looking at it, and with our deviation so low, and this is very flat, we're not even pushing past 0.62 of a pixel's deviation. So for this is pretty much done. This is good. If we zoom in, we can sort of see everything sticking perfectly. All these lines are staying in the right place. So if we press spacebar, stop that. So we're pretty much done now with the tracking of this shot. We've got it working absolutely perfectly. It's working bang on with our set geo, so if anyone's done any animation on it and they're waiting for the camera, they know the camera's going to be absolutely perfect. And this is what would be required from you working in production. So you can't just do an automatic track and just place it anywhere in the scene. It has to work with the layout that someone else has done or provided you. You just won't be able to get away with it. So now we've done that, what we'll do, we'll save it. So if we go to 3D4 and save the project, and what I'll do, I'll just save over the top and click overwrite, doesn't bother me, you can version up. So the next thing we need to do, we need to export our camera, our Nuke LD node for the compositors to reapply the distortion back onto the plate, back onto the CG if they're adding any in. It's very little amount, so it probably won't make any difference, but we'll still do it. And then we'll also do an undistorted plate. Even though there's such a small amount, we'll still do it anyway. So we're going to go to the bottom left here, go to 3DE4, and what we're going to do is export project and go to Maya version 2.5 or whatever software that you're using. We always use Maya because because that's just what we use. We want to make sure our start frame is at 1001, and the reason why it's 1001 is because that's what our image sequence starts at. So this always has to be at the same start frame as your image sequence. So we'll click on export file, and we'll export it to the same place I've saved it. So if I'll call it exactly the same name, exactly the same name as the plate, so we always know that this camera corresponds with this image sequence. So I've called it the image sequence name underscore cam01. Click OK, and this will create a mail script for us to bring into Maya. So then the next thing for us to do would go to File, Export, and click on the Export Nuke LD3D for Lens Distortion node. And this will create us on our Lens Distortion node for the compass. So we want to call that the exact same thing as well. Nuke LD node VO1. So now we know this is the LD node that will reapply our distortion. Click OK, and click OK, and now that's created. So finally, all we need to do is export out our undistorted plates. So what we'll do with this we'll do this in 3D. So if we go to 3DE, click on Run Warp 4, and it will open up this window. And if we go to our warped footage, click Preview, we can click between two and we can see there's almost no different. There's nothing going on here. So if we click on Save the Footage and click Browse, we want to save it in the same place. But we'll make a new directory, call it Garden Table BG01 VO1 UHD underscore UDP for undistorted plate. What I'll do, I'll select all this, right click and copy it, so now I'm going to have to write it again. So what I'll do is select this folder and we'll right click to file and paste. That's really important that we get this right here, otherwise it won't render out. So if we press .4hashes .exr, and this will tell Warp4 that we're rendering out the image sequence. If you don't do that, it will just render out one image. So if we click OK, so the next thing we want to do is we want to scale it down. So we want at least 50% down to 1080p, and we can preview this, and it won't make any difference. So now all we need to do is click render, and this could take quite a while. Hopefully you should start seeing green frames being filled out where it's rendering out. What I'll do, I'll probably fast forward through this and catch you when it's done. Okay, cool, so that's finally rendered out. So what we can do, we can click up here on File and Exit, and you can save your 3DE file. Right, and we're done now for 3DEqualizer. Our next step would be to bring it into Maya, set up our camera, then prep it ready to go for any CG or any renders that you wish to do of it. So I hope you enjoyed this first shot in the course of 3DEqualizer and Matchmove, and you've learned a lot. Yeah, and I guess I'll see you on the next shot. And don't forget to like and subscribe.